Hello, calculus learner. Welcome to another edition of I Wanna Pass Basic Calc. And today, we will be learning the limits involving expressions sin x over x, 1 minus cosine x over x, and e raised to x minus 1 over x. It might sound complicated, but we will make it easy for you. I'm Stephen Chua with my colleague Denise Fuentes, and this is a limit tutorial video. But we are here not to introduce limits, which the value of function whose sequence as the input for index approaches some value. Instead, we're here to introduce the squeeze theorem. Look at this statement. Provided those limits exist. So when the limits on the upper bound and the lower bound are the same, then the function in the middle is squeezed into having the same limit. The goal here is to show that, and to do this, we'll use the squeeze theorem by establishing upper and lower bound on sin x over x in an interval around 0. Specifically, we'll show that in an interval around 0. We can already see why this should be the case by the following graph. Look at the graph. You see here that a function is squeezed in the middle of the g of x, which is the green line, and h of x, which is the red function. Now for the limit of 1 minus cosine x over x as x approaches 0, multiply the function by 1 plus cosine x over 1 plus cosine x, which is also equal to 1, apply some trigonometric identities, and voila, it is equal to 0. For the final function, the limit of e raised to x minus 1 over x as x approaches 0, we can also use the squeeze theorem. Consider this. On the open interval -1, 1, we have using the squeeze theorem, we found out the limit of the left-hand side function, and the limit of the right-hand side function is equal. Therefore, with the squeeze theorem, the limit of e raised to x minus 1 over x as x approaches 0 will always be equal to 1. Now, let's go to Denise to provide you with some examples.
Hi, I am Denise Fuentes and I will be giving 3 example problems using table values and algebraic manipulation.
Yeah, Mr. White! Yes, science!
First example is to find the limit of sin of 5x over x as x approaches 0. In order to match the theorem that the limit of sin of x over x is absolutely 1, which is proven earlier by my partner Stephen, first thing we have to do is to multiply the numerator and the denominator by 5. Now we have 5 times sin of 5x over 5x. As you can see, the sin of 5x over 5x matches the theorem sin of x over x. So now we can say that the function sin of 5x over 5x is equal to 1. Now we write it as 5 times 1, which is then equal to 5. There you have it. The limit of sin of 5x over x as x approaches 0 is equal to 5. There is another method we can use to solve this problem, and that is the table of values. In this case, since the approaching value of x is 0, we'll be using values less than 0 for the x values. I will be using -0.5, -0.1, -0.01, and -0.001, and substitute them in a function. For the x value -0.5, when we substitute it in the function sin of 5x over x, we get 1.1969, or simply 1.20. Next is -0.1. If we substitute it in the function, we get 4.79. Next we have -0.01. Substitute it in the function and we get 4.9979. Next is -0.001. Substituted to sin of 5x over x, we get 4.999979, or simply 5. Observe the table and you will see that the value that f of x is approaching is 5. Thus, the limit of sin of 5x over x as x approaches 0, using the table values, we get 5. So for the next example, we have limit of 1 minus cosine of 3x over x as x approaches 0. A theorem mentioned earlier states that the limit of 1 minus cosine of x over x is 0. In this example, the first thing we have to do is the same as what we did earlier in the first example. Multiply the numerator and the denominator by the value given, which in this case is 3. Now we have 3 times 1 minus cosine of 3x over 3x, where the function 1 minus cosine of 3x over 3x matches the theorem of 1 minus cosine of x over x. We can now replace this function with 0. Then we have 3 times 0, which is then equal to 0. Now we can say that using the algebraic manipulation method, the limit of 1 minus cosine of 3x over x as x approaches 0 is 0. Using the table values, we do the same thing as we did earlier. For x value negative 0.5, substituted in 1 minus cosine of 3x over x, we get negative 1.8585 or negative 1.86. Next we have is negative 0.1. Substituted and we get negative 0.4466 or simply negative 0.45. Next is negative 0.01. Substituted and we get negative 0.045. Lastly, negative 0.001. Substituted in 1 minus cosine of 3x over x, we get negative 0.0045. As you can see, the f of x values are approaching 0. Thus, the limit of 1 minus cosine of 3x over x as x approaches 0, using the table values, we get 0. As for the third example, we have to find the limit of e raised to 4x minus 1 over e raised to 3x minus 1 as x approaches 0. We have to factor out both the top and the bottom part. So we have the quantity of e raised to x plus 1 times the quantity of e raised to x minus 1 times the quantity of e raised to 2x plus 1 over quantity of e raised to x minus 1 times the quantity of e raised to x plus e raised to 2x plus 1. Then we can cancel out the e raised to x minus 1, so we're left with the quantity of e raised to x plus 1 times the quantity of e raised to 2x plus 1 all over e raised to 2x plus e raised to x plus 1. Next step is substitution, where we substitute 0 to all the x in the function. So now we have the quantity of e raised to 0 plus 1 times the quantity of e raised to 2 times 0 plus 1 all over e raised to 2 times 0 plus e raised to 0 plus 1. E raised to 0 is automatically equal to 1, so we can now replace all e raised to 0 with 1. So now we have quantity of 1 plus 1 times the quantity of 1 plus 1 all over 1 plus 1 plus 1, and that is equal to 4 thirds. So now using table of values, we're going to be using the same x values that we used in the first two examples, which are negative 0.5, negative 0.1, negative 0.01, and negative 0.001. For x value negative 0.5, we get 1.11. Next is negative 0.1, substituted and we get 1.27. Next is negative 0.01, substituted in the function we get 1.3267. Lastly, negative 0.001, we get 1.33, which is also 4 thirds in fraction. This approaching value of the f of x values that we got is 1.33 or 4 thirds in fraction. We can say that the limit of e raised to 4x minus 1 over e raised to 3x minus 1 as x approaches 0 is 4 thirds. And now that you've learned how to solve problems about limits involving expressions sine of x over x, 1 minus cosine of x over x, and e raised to x minus 1 over x, it's now time to test yourself. Answer these 5 questions and see whether you fully understand the lesson.
And that's it. Thank you for watching. Again, this is Chua and my colleague Denise Fuentes, and thank you for watching. I wanna pass basic.
Wow!